aircraft, we don't use such a component, okay, like a missile kind of or bomber kind of things. We will not assemble because for commercial aircraft we don't need such component. No? Okay, whereas in case of fighter aircraft or bomber aircraft, so we'll prefer such components. So that's why once if you have any plan like to analyze your aircraft with the pods, okay, especially with addition of missiles or with addition of bombs, okay, so such kind of aerodynamic analysis can be done once if you done with this kind of complete assembly part. So after that we can analyze the same assembled component in the open VSP. Okay, so today I'll be telling about parameter. Okay, for design parameter, suppose you'll get a design parameter like this, translate along three axes, which means it designs any such pod, okay, and place somewhere to your aircraft below the fuselage, okay, by translating along three axes and add rectangular or ellipse subsurfaces and increase length and fineness ratio to 50. Okay, suppose this is your pod design parameter. So this parameter, according to this parameter, we can design our pod. Okay. So whatever we have done yesterday, that is just a rough pod design. I mean, like some rough model I have done. So like this, we have different aircraft. Let me open the OpenVSP software. Yeah. So I will add pod. So I have to translate along three axes and x along y along z. Okay. So this model has been translated along three axes. Okay. Subsurface and rectangular. Select the rectangular type subsurface. Add. You can observe the rectangular surface has been added here. Okay, somewhere sometime you'll design such kind of pod where you have such rectangular objects like or rectangular kind of shape with pod. So yeah, for this you can change its length, width, and tessellations. Okay. So currently I have not given any such changes or in this parameter. I have not asked anything that with respect to the rectangular subsurface, right? Just have to just add rectangular and ellipse. That's it. Okay. So that way, just I will add. I will not do any alterations with these parameters, subsurface parameter, especially for rectangular. I'll just remain. I will just keep as it is the default values. Okay. And similarly, I'll add ellipse. Yeah. So for this case also, we should not disturb anything. So just what I'll do, just to differentiate this rectangular and ellipse, I'll just translate this rectangular little bit forward. So maybe this one. Yeah. So increase the length and fineness ratio to 15. So now I'll come to design parameter. I'll increase the length and fineness ratio to 15. Fineness ratio already is 15, so length I just maintain 10 to 15. Okay. Because yeah, so according to the design parameter, this part has been done. So just I will shade material. I am not given anything. Just let it be the default material. Okay. Now this part, suppose if you want to assemble or if you want to attach to the aircraft, so let me take out one aircraft. Okay, let me copy once again. So let me select this commercial flight. No need for this. Okay, let me select this model one which I have designed. Okay. So that power component got deleted. No problem. Let me add once again. Okay, and let me translate this. Okay. Suppose if you want to place here and let it be this side itself, and just I have to add the ellipse surface and rectangular surface. Let it be the default subsurface parameters. Design parameter, I'll just change the length 10 to 15. Yeah, I'll share this, and also I'll share this complete model. I will select all. I'll shade. Yeah, I'll move this part. Okay. We keep this complete model right view, front view. Okay, yeah. So now I can fix this. Yeah. Yes. So according to the given parameter, okay, the pod has been designed according to the given parameter, and of course, once you design if you want to assemble, or if you want to fix, or if you want to attach below the fuselage, you can attach, or else if you want to attach somewhere. Okay, so just you have to select that particular pod component, and you have to come to X form. You okay, wherever you want to attach that pod component, just you vary these locations along X, along Y, and along Z, which means you can translate your complete model, this pod model. You can fix to the required location. Okay, and yeah. So similarly, suppose if I want this side, then no need to design once again the same pod component. Okay, just copy this and paste. Okay, and after that, just translate that model along Y. Just like this. And share it. Yeah, by keeping in this all views, what we have: top view, front view, left view, ISO view. Okay, so you can uh, use these options just to analyze your assembled part or attached part, whether that has been attached properly or not. Okay, so I'll just select all window, four window. Yeah, so like this you can analyze. I mean, you can have a look to your model with respect to the top view, ISO view, front view, and the side view. Because if you're going for any kind of paper publication and all, if you capture this kind of views, and if you insert or if you add this kind of figures, then it will be attractive, right? Figures, especially for that particular paper, this kind of figures will be very much attractive. Yeah, so like this, you can even save. Let me change this four window into one window. Suppose you want the same pod this side and also this side. I mean, like two more extra pod. Similarly, like no need to design the same pod model. Just copy and paste, and after that, just translate your model along Y. Somewhere here. Okay. Similarly, you can select this one. After that, you can copy and paste. and just translate that along y. So this is done now. Yeah, after that just select that new part component which you have copied and here pasted it. So just select that and shade. So currently the material is default material. Okay, just I wanted to show that you can fix your number of pod components. Okay, not only one, two, or three, as per your requirement, like four, five, six. So that many number of pod component you can copy and paste. The only thing is that more time will take only for one pod component. So once if you done with the particular first pod component, if it is the same, okay, I mean, like if you want to copy the same pod component, okay, on other side, okay, then just copy and paste. Now I have to select this one and just share this. Now you can have a look for views. It's looking good, right? So pod plane, okay, it is designed principle for an aircraft where payload carrying sections can be routinely detached, or even we can attach. Okay, we can increase our wing loading, we can decrease our wing loading. And like if you don't need this pod component, then just detach that. So pods are the smallest deployable object as compared to the main wing and the fuselage and all. So here one more important thing I want to tell with respect to this pod. Let me change the window 4 into 1. See here. Yeah, let me convert this shaded into wireframe. Yeah, okay. So here, if we increase the number of tessellations, see here we have tessellation. Okay, as I increase the number of tessellation, okay, that will indicates that you are smoothing your geometry. Okay, this geometry. See, here we have one pod and one more. I'll select and I'll change this shaded into wireframe. Yeah, okay. See, and yeah, wait. Yes, this one and this one. What we have? Yeah, this third one and the fourth one. Okay, this is our first pod, second, and third. In this second case and the third case, geometry what we have pod geometry. Okay, in this case, the number of tessellations just 10 and 9. Okay, whereas in this third case the number of tessellations I have increased, okay, from default to 47 and 81, which means as we increase the number of tessellations, okay, tessellation that gives smooth geometry. Okay, so if you want to smooth your geometry, okay, especially the pod geometry or the component what we have, okay, so that smoothing can be done by just increasing the number of tessellations like this. And here the design parameter of this pod, that is length and the finesse ratio. So the finesse ratio, as I told yesterday itself, that is the ratio of length to the maximum dia of this part. Okay. So this I have, let me change this. Let me select this fourth, third one. Okay. Yeah, sorry, second one. So in this case, as I told, the finesse ratio is the ratio of the length to the maximum dia. Okay. So here, if suppose if you increase the finesse ratio, see here I am increasing finesse ratio, then the pod model what we have, okay, second model, that will become more cylinder if I increase, see. So now suppose this is 20, now I'll just increase 20 into 30. So see, increasing the finesse ratio, then the pod model becomes more cylinder. And if we decrease the finesse ratio 30 to 26, 27, or 10, see here. So if we decrease the finesse ratio value, or if we maintain a small finesse ratio value, then the model will become more broad. Right? So these things you have to remember. Okay, in this pod case. So for today, this much is okay because this is very small geometry, but where we have less parameters. So almost I have done. Okay. So this is all about today's topic. We'll continue tomorrow. Let me share this. See, I have increased the finance ratio, right? And overall length. So that's why this pod has been changed. Initially it was same, right? So now it's changed. So like this you can do alterations and you can fix your required geometrical part. Okay. Yeah. So this is all about today's topic. We'll continue tomorrow. Thank you to all. So done for the day. Thank you.
Okay. Thank you, sir.